Perfect. Well, nice to know I'm talking about a crazy subject. But thanks for having me. I'm here to talk about the Green Brain Project. But ultimately, my primary interest in UAVs is enabling the everyday user through autonomy. And actually, that's my interest in the Green Brain Project. So I think if we're ever going to get a consensus on this topic, it's going to be in this room, and that is the future world of drones looks incredibly exciting. This is mainly due to their vast and diverse uses and configurations. But really, to enable this widespread use, we need to push two main areas. One, regulation, which I'm not going to touch with a 10-foot pole, and two, autonomy. But really, to enable autonomy and autonomous drones, we have to understand the world in which the drones operate. And unfortunately, the world, according to our drones, is three things: uncertain, complex, and dynamic. So given an uncertain, complex, and dynamic world, how do the best of the best robots really do? And I think this is perfectly highlighted through the recent DARPA challenge, which envisioned this disaster relief scenario and threw the best of the best teams at this. And this is how they did. And I love this video because it just makes me laugh. But it reminds me that the robots are not taking over the world anytime soon. Furthermore, these problems are not unique to humanoid robots. In fact, they're compound for our drones because they require, they have much more restrictions on weight and power, and they require much faster control systems. So it begs the question, is there an answer, and is there a solution? And the answer is yes, there is a solution that's been worked on for millions of years and has been recognized often by control. And that is Mother Nature, of course. And of course, we have no idea how it works, but we know the solution's out there. And this is really what has inspired the Green Brain Project, particularly the honeybee. We know that they're excellent navigators, and despite their small brain size, they have incredible cognitive abilities. So this is what we're focused on in the Green Brain Project. What we're trying to do is, like Philip said, create a complete computational model of the honeybee brain and use it, our drones, to embody it. So as you can imagine, we're a big group. This is quite a big task. It's not just me. And we do lots of different things. One, we focus a lot on behavioral and neurophysiological experiments to tell us how these bees are interacting given controlled stimuli and situations. We develop a suite of computational tools that allow not only the creation and visualization of these neural models, but also the implementation on various hardware. We're particularly focused on running these on GPUs, because similar to our nervous systems, they allow for massive parallel computations. Which brings us to the bread and butter, computational modeling. If you want to understand a living system, it means trying to duplicate it. And for us, that means creating models. And of course, brains don't exist in an isolated world, or even an IBM computer. They have a body, and they have actuators, and they have sensors, and they interact with their environment. So this means we create bio-inspired and biomimetic UAVs. And again, since a lot of what honeybees do is navigation, using various sensor modalities, that means bio-inspired navigation for UAVs. So if we want to be able to do high-level things like learning and create memories, it means we have to really understand the inputs into these systems and map them correctly. So to do this, we've replicated this wide field of view, and actually quite coarse field of view, using two first-person view cameras, which replicate the near panoramic capability of the honeybee vision. And using a little bit of stitching, pixel selection, you get bee vision. And despite what we all normally want and need, they don't need the same resolution as we do. They can do quite sophisticated navigation tasks with essentially this really blurry image. So once we've accurately measured or represented the world, we can create much more interesting things like models of their visual system, which are very well known to accomplish things like navigation using motion detection. So here is just an example of one of the things that we're doing with our drones, and that is replicating how bees are able to balance motion detection in their eye for control of their yaw and their pitch. And here's just a little video of that working to accomplish this corridor centering or wall following. We also do a bit of olfactory classification and learning, as we know that honeybees also use these sensory modalities for navigation. Unfortunately, as you can imagine, the quadcopters generate a lot of mixing of the air, so it's really problematic trying to do these experiments on our quadcopters. But similarly, we use this array of sensors, as you would see in a bee, to do classification and olfaction. So with that, I'll wrap up, but I just want to make a little bit of a plug for the next phase of the project. We're wrapping up our 3-year grant, and we're looking to the future. And as you can imagine, our drone is already a little bit out to date, because that's how things work. But what we really want to do is improve our technology so that we can not only further develop our models, but we can push some of these navigation abilities further to deployment. And that means more sophisticated drones. So we want to do things like move our brain on board using new chips, NVIDIA chips, and things like the Myriad 2 from Movidius. So if any drone companies are interested in something like this, we're very open to industry partners. And of course, I need to just say thanks to the group, because of course I don't do all of this alone. It's very much a team. So with that, I'll say thank you.
Thank you.